Hi guys. Hey, we're doing section 11.5 and it is on adding and subtracting with common denominators. So remember the rule when we add and subtract fractions, like if I have a half plus 3 halves, I add my numerators and I get 4 and my denominator stays, and then I simplify my answer. And so that's exactly what we do here. And we don't have to worry about excluded values unless we cancel a variable term. That's the only time. So there will be, sometimes when you simplify, you will have to cancel something out. Just like here, I technically canceled out 2 because 4 is, if I factor 4, that's 2 times 2, and I canceled those out. And so we will be doing that to simplify things, but otherwise, I think most of you will think this is somewhat tedious because there are a lot of little things to do, but I don't think it's hard necessarily. If you could hear Steve laugh in the background, he has a loud laugh. They're playing guitar. Okay, so I have 5x over 3 and 4x over 3, and I'm adding them. And so because they're both over 3, my denominator carries over. I don't have to change the denominator or get a common denominator, which is what is nice about this lesson, because all of them are like that. So I just add my numerators. So 5x plus 4x is 9x, and then I simplify. So that's 3x. And I'm done. Okay? Similarly here, I have 3x over x minus 3 plus 4x over x minus 3. So some of you will be able to do this you'll be able to skip steps here, but I'm going to, for the sake of understanding, write this like that in 2 steps. So I can add those, and so that means I have 7x over x minus 3. So you can think about it like that as well. I can't do anything with that. I can't cancel my x's, okay, because this is subtraction here. I can only cancel things if every term in the numerator and every term in the denominator are being multiplied by each other. So, like, there has to be that multiplication going on. And down here, this isn't. It's just x minus 3. That's the number, x minus 3. And so I would have to have an x minus 3 in parentheses on the top to cancel. So that one is done. I don't have to worry about excluding anything because I didn't cancel anything. And anybody looking at this knows that x can't be 3 because that would make it 0. Okay, so those are the easiest ones. Okay, let's go down to this one. So I'm just adding. Okay, so I need to add my like terms. So I end up with 8x cubed. I have 7x squared minus x squared. So plus 6x squared. Minus 3x plus 5x would be plus 2x. And 1 minus 1 is 0. So I don't have that anymore. And then I have 4x in the denominator. Okay. I'm not done because I need to factor. So the first thing I'm going to factor is a 2x from the top. So that leaves me with 4x squared plus 3x plus 1. And look at this. I can also factor a 2x out of the bottom. Sorry, I wrote that wrong. I can factor 2x out of the bottom because 2x times 2 is 4x. Okay, I'm going to keep rewriting 2x and 2x times 2. Okay, so I need to factor here if possible. So look at it for a little bit and decide if we can do that. So remember that we have to multiply to get the 4, and we have to multiply to get the 1, And then we have to come up with some way of multiplying these and adding them to get a 3. 1 times 1 is 1, and 1 times 4 is 4, and 1 plus 4 is 5. 2 times 1 is 2, 2 times 1 is 2, that's 4. I don't think there's any way for me to get that 3. You have the benefit that you have the answers sitting there, and so that can help you. So that's one thing that you can do. If you also go back, I'm looking at my book. I have to go back to chapter 9. In chapter 9, on page 328, there's this test for seeing if we can factor a quadratic. So in order to do that, you check this. So you find the discriminant, and you see if it's a perfect square, and if it's also positive. So, which it'll need to be. So, that b squared minus 4ac, we can test that out here. So b is 3, so that's 9, minus 4 times my a is 4, and my c is 1. So this is 9 minus 4 times 4 is 16, times 1 is 16, so that's negative 5. That's not positive, it's not a perfect square, so that means that I can't factor. It's, so it's unfactorable. So that means I'm going to leave it. Okay, so if you do that little test, that can help you to save you from doing a lot of effort to trying to figure out if it's factorable or not. You just have to make sure you do your math right. So let's look at one of these up here so you can see how that works. Like this one is 2x squared plus 7x minus 15. So this one was factorable. Let's do that test on it. So b squared minus 4ac. b is 7, so that's b squared is 49. And then we're going to subtract 4 times 2 times negative 15. So I have 49 plus, because notice I have a minus, I'm subtracting, and I have a negative. So that's going to end up being positive. 8 times 15 is 40 plus 80 is 120. That's 169. And the square root of 169 is 13. So this passes the discriminant test. So it's handy to keep you from doing a bunch of work. It doesn't give us the answers, obviously, but it helps us to know if we should even bother trying, which can be helpful when you're getting frustrated and not sure. And then you don't have to just give up and not know. So that means I don't need those inner parentheses. So I have 4x squared plus 3x plus 1. My 2 x's are going to cancel out, which means that x cannot equal 0. Okay, that's important. And then my answer that I'm left with, you can write, and you could write this a couple of ways, but I think they're going to want you to have it in a specific way. To just leave the 2 in the denominator. So 4x squared plus 3x plus 1 over 2. So it's not like a super simple, pretty clean answer, but it's the answer, and we know that we did everything we could because we can't do any more factoring. And even if we did factor more, look, there's nothing else to cancel with. I'm not going to cancel out that 2. If there was something fancier down here, like x plus 1 or x minus 3, that might be a clue also that this could factor more. It doesn't mean it will, but it could be a clue that that could factor more. So let's look at our next example. So I have a longer problem here, and this it isn't a subtraction in here, but I do want to notice that this is a negative x and that's a negative 6. Okay, so everything is going to end up over 8x squared minus 2x minus 1. So I'm going to combine my like terms. So I have 3x and 2x and negative x, which is 4x. And I have 11 and 4, just 15, minus 6 is 9. Oh, I wrote this problem down wrong. I'm sorry. Change this to a negative. If you're following along in your book, you probably caught that already. So that changes this. 11 minus 4 is 7, and 7 minus 6 is 1. There we go. Okay. Now, here's one where, even though this denominator isn't something you're like, ooh, that looks factorable, the fact that I have this 4x plus 1 up here is kind of a clue to me that maybe I can factor a 4x plus 1 out. And remember, this makes it easy because you only have one option. If this is a factor, there's only one thing that can work over here. So it saves all of that guesswork. So I'm going to say, hey, because this ends up here, because it's a math book and they're coming up with problems for kids to do to help them to understand it, it's probably going to factor out. If not, it doesn't, but it's a good thing to try. And again, you only have one thing to test, so it's not like you're missing out on a bunch of time. Sorry, this has to be a 2. There we go. So I have to multiply by 2x here. And so then I need the number here that I multiply so that I get this negative 1. So it has to be minus 1. So if it works, it works. And if it doesn't, it doesn't. That's, you know, that's all that you really have to check. You either check it and see if it works. And if it does, then that's great. And if it doesn't work, then 4x plus 1 isn't a factor. So here I get 2x, and here I get negative 4x. And when I combine those, that gives me negative 2x. So I'm on the right track. This is correct. So that means that cancels. Okay? So I'm left with 1 over 2x minus 1. And this is that, I have to remember that I canceled out 4x plus 1. So 4x plus 1 cannot equal 0. So I need to solve. So x cannot equal negative 1/4. Okay? Oh, sorry. X is not equal to negative 1/4. Okay. These problems, the next problems are subtraction problems. So here I have my x's in the denominator and I'm just subtracting. So 4 minus 3 is 1. So my answer is 1 over x and I'm done. I don't have any answers to exclude for x because I didn't cancel it out. Okay, 3x minus 4. I just write that down. 3x minus 4 over x plus 1. I can't do anything else with that. And I also didn't cancel anything, so I don't have to worry about any excluded values. Okay, so then I have this last one. So let's combine things here. So I'm going to go 2x minus x. I guess I'm going to have you pause. When I'm subtracting this whole thing. So that means I'm subtracting x, but I'm also subtracting that 2. So don't forget about that negative distributing through there. So it could help you to rewrite this like this so that you don't make that mistake. Okay? And then you can simplify it. But some of you will be able to do that without worrying about it, but it's a good thing to check. Okay, so that gives me x, and then 1 minus 2 is negative 1. And then I am going to say, because we're doing math, and it's in a math book, and I have this x minus 1 on top, I am going to try to factor out an x minus 1 for my denominator. So I know that it's just x's out front, and now I need to think, what do I multiply by negative 1 to get a positive 3? So it's just negative 3. So this gives me negative x and negative 3x, which gives me negative 4x. And negative 3 times negative 1 gives me a positive 3. Okay, so again, I'm using what I know that typically somebody who's writing a textbook for kids to work out problems is going to have some things in there that are kind of not really a clue, but it's just set up so that it's easier for you that way. Okay, so these x minus 1s will cancel, and that sets off in my head, oh hey, x cannot equal 1, because 1 minus 1 would make that 0, and that can't be 0, because 0 times this would be 0, and I would be dividing by 0, and dividing by 0 is bad. Don't divide by 0. But then I'm left up on top with a 1, and on the bottom my x minus 3. Okay? So the problems in this section are that they're adding and subtracting, so make sure you're paying attention to what it's asking you to do. And make sure you're paying attention here when you're subtracting, more than just a single term, that you're subtracting everything there. Even though there aren't parentheses, if I'm subtracting this whole thing, because that's a number, and that's what I'm doing, I'm subtracting this whole thing, that means those things need to be subtracted. Your denominator stays the same, because that's a rule that's set in stone. We have the same denominator, we keep it the same, we don't change it. Okay? Our next lesson, we get to find common denominators, which is so much fun. I know you're excited about it. Okay, so again, if you have questions, please feel free to call me, text me, send me a picture, do, those things. Again, make sure I know what you're asking. Show me what you've done. Those things help me to be able to help you to understand how to do it well. This will really, really help you next year. I think you guys are going to come out ahead of the game when it comes to kids entering the next math class. I think it will go really well for you. So I will see you next time. Next week we'll start 11.6. So if you've done 11.3, 11.4, and 11.5, then you are done for the week of April 6th through 10th. All right? Hey, be sure to let me know if you need help. I will talk to you guys later.